All right, so here we're taking a look at the core problems for 3.1.1. This will be page 131 in your textbook, and just problems 1 through 6. So only 6 problems for today. So let's go ahead and get started. All right, the first problem, 3-1. Katrina wrote the following set of instructions for Cecil. 4 times 2.5 plus 1. If Cecil the acrobat follows Katrina's instructions, how far will she go? Draw a diagram of Cecil's movements and show how far he will move. Okay, so let's go ahead and start with our diagram here. We need to think about our PEMDAS, our order of operations. So we're going to do the multiplication first because that comes before adding. And so if we do 2.5 in the positive direction 4 times, it'll look like this, right? 2.5, 2.5, 2.5, 2.5. If we want to keep track, it would be 2.5 here, and then we'd be at 5, and then we'd be at 7.5, and then we'd be at 10. And then we also have to go one more. So I'm going to do a little one here, and that's going to be one more. So we're going from 10 to 11. That'd be our ending point. So how far will he go? 11, and it doesn't say feet or yards, so we just put 11. And then draw a diagram of Cecil's movement and show how far he will move. Well, we have that diagram right here, so we can check that off. Katrina drew the diagram at the right. How was she thinking about Cecil's moves? Write an expression to represent Katrina's diagram. Okay, so here now we see Katrina's diagram and her mindset. So it looks a little different from ours. Notice that she instead has added 1 4 times instead of the 1 time that we just added it. So how is she thinking about Cecil's moves? How can we answer that? Well, we could say that she was thinking of doing 4 times 2.5 plus 1 in parentheses. So she added before she did our multiplication. Write an expression to represent Katrina's diagram. Right here. 2.5 plus 1, 4 times. Right? Here would be 1 time. Here would be 2 times. 3 times. 4 times. Explain why Katrina's diagram in part B will not give her the correct length for 4 times 2.5 plus 1. Well, we said the correct length was 11, right? And so if we were to add together all of Katrina's pieces, well, we'd have 2.5 plus 1, which would be 3.5. And then we see it 4 more times. And so we just do 3.5 multiplied by 4, which, let's see, 4 times 3 is 12, and 4 times 0.5 is 2. So 12 plus 2 is going to give us 14. So obviously 14 is greater than the distance of 11, so you're not going to get the same answer. Part D, Cecil changed Katrina's set of instructions so that the length of 1 foot came first, as shown in the diagram at the right. Okay, so very similar to our diagram that we see up here, except this 1 is now at the front. Write an expression to represent this new diagram, and then how far does Cecil move here? Does it give you the same length as 4 times 2.5 plus 1? So our new expression would be that 1 comes first, and then we are adding it by the 4 times 2.5. So we need to make sure that we have our parentheses here, because then it shows that this is grouped together, right? We always start with multiplication anyways before we add or subtract. And then if we were to solve this here, we'd do our multiplication first, and we would end up with 10, 1 plus 10, that equals 11. And so yes, we would travel the same distance no matter whether we put that 1 at the end like we did in our diagram or if it's at the front. All right, now we're looking at simplifying the following expressions. So we have 3 of them here on our screen. So Cecil's trainers proposed each of the following movements. Which one requires the longest rope we're going to draw diagrams to justify our answers. All right, so let's start off with the first scenario. In this case, let's go ahead and write PEMDAS at the top of our paper. And that just reminds us parentheses and then exponents, and then multiply or divide, whichever one we see first from left to right. Same with adding, subtracting, whichever one we see first. So here we see 8 plus 2, and then in parentheses 6.48. Remember, this just means that we are multiplying them together, but we try not to write with x's here because that could be a variable. So what are we going to start with here? Thinking of PEMDAS. Do we have any parentheses? And we do, but 6.48 is by itself. What about exponents? Do we have any exponents? No. What about multiplication? Yes, we do have multiplication, right? So if we do 2 times 6.48, that's going to give us 0.96. When we do 2 times 4, 8. And then we do 2 times 6, that's going to give us 12. Then we have 8 plus 12.96, and that's going to give us 20.96. So that's how far we traveled in the first example, part A. So now we're moving on to problem B here. And again, we're going to look for PEMDAS. So we have 2 plus 8, this time on the outside of the parentheses, and then 6.48 on the inside. So we're multiplying first, right? That comes before adding. So we're going to rewrite that 2 plus, and then what 8 times 4.8 would give us. Let's see. Well, first we can start off by doing 8 times 8. That gives us 64. Carry our 6. 8 times 4 gives us 32. Plus our 6, that's going to give us 38. And then we have to carry our 3. 8 times 6 is 48. Plus that 3. And there we should have 51.84. All right. So if we do 51.84 plus 2, we're going to get 53.84. All right, and then we're looking at the final problem here, part C. We're going to need a little bit more room. I'm just going to go ahead and do part C right where we did part B. And here it's in parentheses 8 plus 2 multiplied by 6.48. All right, so do we see parentheses? Yes, we do see parentheses here, right? 8 plus 2, and so we're going to do that first. And then we have 10 multiplied by 6.48. So this may look kind of difficult, but really, if we're multiplying something by 10, all we have to do is move that decimal place over one spot, right? And so when we do that, we're going to have 64.8. So which number is the biggest? Well, we had 64.8 feet here. And then we had 51.84 for the second problem. And then the first one, that was only 20.96. So here, which one's the biggest number out of 20, 51, and 64? It's going to be that 64.8. So the expression in part C is going to get us to go the longest distance. Now notice we're using the same numbers. It's just a matter of how we're writing our expression and using parentheses and multiplication. All right, now we're looking at 3.3. And it says here, the expression 5 plus 3 times 4 plus 2 can be used to represent the group of positive tiles shown at right. Positive tiles are actually right here, down at the bottom, so lower left corner. Work with your team to explain how each part of the expression connects with the group of positive tiles. How many tiles are there? Okay, so let's first start off with in yellow. looking at the 5. So here is our positive 5 represented by 5 positive tiles. And now we're going to do in green 3 times 4. So that's our next part here. You can't see it based off of how it's put onto my smartboard, but it's going to be 3 groups of 4. So here we see one group, we see a second group, and there's a third group down here of another 4 positive tiles for a total of 12, right? So that's where the 3 times 4 is shown. And then we have to end with in red our positive 2. All right. So here we have the expression of 5, 3 times 4, and then 2 at the end. All right. How many tiles are there? Well, first we would start with our multiplication. And if we do 3 times 4, that's going to give us 12. And then we have our 5 and 2 still. 5 plus 12 is going to give us 17. Plus 2, that's going to give us 19. So this time we worked up instead of working down because we didn't have any room. But we started with that multiplication. So the next question is, each group of positive tiles is represented by a different part of the expression, also called a numerical term. All right, so for example here, 3 times 4 would be a numerical term. We have to solve out what 3 times 4 is before we can solve the rest of it. It is often useful to circle terms in an expression to keep track of separate calculations. For example, each term circled in the expression below represents a separate part of the collection of positive tiles above. All right, so just like we showed, started with the 5, and then the 12, and then the 2. All right, so now it says circle the terms in the expression below and explain what each term could describe about collections of positive and negative tiles. All right, so let's start off with circling the terms. We'll do it in this light green here. It's a nice color. So 4 times 5 would be a term, right? That's not standing alone. And then 3, and then in parentheses, negative 2, or 3 times negative 2. That's another numerical term because that doesn't stand alone. And then we can just go ahead and circle the ones that already do stand alone, and I'll do them in a different color, 6 and 1. So here we have 1, 2, 3, 4 terms. And obviously we would need to solve what 4 times 5 is first, 20, and what 3 times negative 6 is first, or negative 2 to get negative 6, before we can solve and simplify. If we had to describe it as a collection of positive and negative tiles, well, we could say 4 times 5 could be 4 groups of 5 positive tiles, right, the plus ones. And then obviously the 1 would just be a positive tile, and then we have 3, and then in parentheses negative 2, so that'd be 3 groups of negative tiles here. And then we just have our positive 6 at the end. All right, now it says circle the terms and simplify each expression shown below. So if we're going to circle the terms here, this stands alone, this stands alone, this stands alone. Nice and easy, 3 terms there. 7.8 stands alone, and then this here does not stand alone. We have to multiply 2.1 multiplied by negative 3. That's going to give us, let's see, 3 times 2 is 6.3. And then we do 7.8 plus 6.3. Ooh, but this is negative, right? We need to multiply a negative by a positive number. You're going to get a negative. So here we're basically subtracting 7.8 minus 6.3. And so that's going to give us 1.5 as a final answer. And then for C, we just solved B. For C, we're going to do this first term here, and then we have another term here. All right, they both don't stand alone. So if we're doing 5 multiplied by a number, in this case, times 3 over 5, negative, we could write that 5 as 5 over 1. And then we can just multiply across the top and multiply across the bottom. So if we do 5 times 3 up top, that's going to give us 15 over 5. That's going to give us 5. We can simplify that. 15 divided by 5 is 3. And since this is a positive number multiplied by a negative number, our answer is going to be as a negative number. And then we need to add it to what 2 times 1.5 is. In this case, that's going to be 3. So negative 3 plus 3, it's going to give us 0. All right, so I just went through and simplified those 2 middle problems, part B and part C. And so now I'm going to leave it up to you guys to simplify A and D. And now we're looking at grouping challenge. Work with your team to add parentheses to 1 plus 3 times 2 plus 8 plus negative 4 so that the resulting expression has the smallest possible value. Then find a different way to add parentheses to the same expression so that it has the largest possible value. For each expression, draw a diagram of how Cecil would move.